next example, we don't have a geometric series anymore. All right, the reason why it's not geometric is we've got, instead of the -2, we have a square root of n in there. So our terms are not increasing geometrically in that regard. What do we need to do? Well, this is where the ratio test comes into play. All right, so if you remember from the ratio test, it's the absolute value, it's a limit as n approaches infinity of the absolute value of the n plus 1th term over the nth term. All right, and that test converges as long as the result is less than 1. Well, now when we're finding our terms, we're going to have x involved, so we're going to have some kind of relationship, some kind of inequality that involves the absolute value of x, and that's going to lead us into our interval of convergence. But before we find the interval, this part of the example just wants us to find the radius of convergence. Okay, so that's looking at getting x isolated in the absolute value in that regard. Okay, so what's going on? Let's set up our ratio test. All right, so we have the limit as n approaches infinity, and remember we're going to divide our n plus 1th term by our nth term. Now, keeping in mind that both of our terms are going to have fractions themselves, so because we're dividing by a fraction, that means we're really multiplying by the reciprocal, just like we did with the ratio test in earlier videos. So I'm going to set that up right away. All right, so I've got my absolute value marker, and then I've got my n plus 1th term right here, and then x to the n plus 1 over 3 to the n plus 1, and I'm going to multiply it by the reciprocal of the nth term. All right, so what does that mean? We're going to have 3 to the n up here, and we're going to have square root of n and x to the nth down below. And I need this to be less than 1. All right, there's my ratio test. When this is true, for whatever values of x that it happens to be true for, that's guiding us towards our radius of convergence and our interval of convergence. And again, what I did is I have my n plus 1th term, and I divided it down here, technically, by the nth term. But dividing by the nth term is the same thing as multiplying by the reciprocal, so I took the reciprocal of that term right there. Now, just like in our convergence test section, we need to simplify this mess right here. Okay, so what does that entail? Well, it entails that this is really x to the nth times x, all right, and that this is, where are we? Here we go. That's really 3 to the nth times 3. That's going to allow us to eliminate some items. Okay, so we know that the 3 to the n's are going to be gone, and the x to the n's are going to be gone. So now what we have here are some terms. We have a constant term, we have some n terms, and then we also have x, and it's all inside the absolute value. But an important thing to keep in mind here is, what is an absolute value helping us out with? All right, well, it's taking negative items and it's allowing them to become positive by looking at the distance that item is from 0 on the number line. Okay. Well, think about the n terms for a second. N starts at 0 and is heading towards infinity, so n is going to be positive. So the n part doesn't actually need to be within the absolute value. So watch what I'm going to do here. I still have my limit as n approaches infinity, okay? But the n plus 1 under the radical, that's going to come out of the absolute value, as is the 3, because that's already positive, as is the absolute value, excuse me, the square root of n, right? But this x could be negative, so I'm going to leave any x term, and that happens to be the only x term, inside the absolute value markers. And that limit still needs to be less than 1. Right? Because now what I can really do is the x doesn't really apply to the limit. The limit is focusing on when n is heading towards infinity. I can now figure that limit out. Right? I can see that my numerator and denominator are growing at the same rate, the square root of n. Right? But my denominator has been tripled. Right? In essence, the degree of both the numerator and the denominator are the same value. So I'm looking at the coefficients of the leading terms. The leading term for the numerator is 1, for the denominator is 3. So this limit right here is heading towards a third. All right, so what does that mean? Well, that means I now have, this is going as 1/3 times the absolute value of x is less than 1. To get the absolute value of x term by itself, I'm going to multiply both sides by 3. All right, so I have the absolute value of x is less than 3. This is my radius. Okay, my center is at 0, and my interest is less than 3, so my radius, or capital R, that's going to be equal to 3. All right, and in the next video, we'll go into the actual interval of convergence.